Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 27. Today we'll be talking about CPCTC. But what is that? Well, we're going to learn to use the corresponding parts of congruent triangles, and then we'll discuss different types of proofs. So as a review, in our last few lessons, we had talked about possibilities of proving two triangles congruent with just taking into account 3 of the 6 measurements. Which one of these worked? When we have 3 pairs of congruent sides, could we prove that they were congruent? We could. What about a side with the angle in between and another side? Could we prove that the triangles were congruent? We could. What about an angle and then a side and then another angle? Could we prove that 2 triangles were congruent? We could. How about a side, an angle, and another angle? Well, we know that the third angle is congruent, and then with one side to assess our length, that was useful. What about side, side, and angle? This one did not work. There are multiple ways to draw a triangle when you have only 2 sides and one angle that's not in between. So this did not help us prove congruency. What about angle, angle, angle? While that makes similar triangles, they could be very different sizes. So this one also did not help us prove congruency. But back to CPCTC. Well, from the definition of congruent triangles, if 2 triangles are congruent, then the corresponding parts of those congruent triangles are also congruent. If we take the first letters of that, the corresponding parts of those congruent triangles will be congruent, then we use the letter CPCTC to refer to that definition. It's useful when we're working with triangles. Let's look at how that can be useful. In this figure, there are the segments AB and CD congruent. So AB is the one up here, and CD is the one down here. Use deductive reasoning to explain why or why not. So we can see that AX and XD are marked as congruent, and we can see that angle B is marked as congruent to angle C. What else do we need to prove the triangles are congruent? Well, again, we had side, side, side. We had side, angle, side, angle, side, angle, or angle, angle, side. So which one of these are we able to use? Well, we have one side and one angle, but it's not going to be the enclosed angle because we don't have either other side. Could we maybe find another angle that's congruent? So we're looking at maybe using one of these two. If we could find another congruent angle, I see that this angle, AXB, is congruent to CXD because they're vertical angles. So with vertical angles, the given congruent angles and the given congruent sides, we can use angle, angle, side, this angle, the middle angle, and the side to prove that they are congruent. So angle, angle, side, after we say that these two vertical angles are congruent. So how do we write proofs? Well, we want to make sure that when we prove something in our argument that we're keeping track of it on our picture. In the last one, I drew the congruent angles when I said these vertical angles are congruent. It's a good idea to mark the segments or angles that you just proved were congruent. This allows you to see on your figure what you've already proved so that you can make more conclusions. It can be hard to remember all of these if you draw them all first and then write them. Did you cover all the ones that were written? Did you draw all the things that you wrote? And sometimes it's hard to keep track if you don't keep good notes. If the figure is overlapping, sometimes it's easier to redraw the parts separately, or maybe use different colors to highlight the different shapes in the figure so that you can tell them apart. Another way to write a proof is a step-by-step proof instead of a paragraph. So in that last one, we just talked through the deductive reasoning. You would have had to write the paragraph or the sentences or statements on your own. We're going to look at a step-by-step proof. I find that it's easiest to write what you're given first, and then you start figuring out other things from what's given. So based on the given, what else can you figure out? Or based on the way that it's drawn, what can you conclude? You're going to write your statement and the reason that you know it's true. Don't get caught up too much in the wording of your reasoning. Just make sure that you're giving a good reason, like vertical angles are congruent, and not just rewording your statement and saying that those two angles are congruent. Mark it on your drawing, and then keep going until you've proven what you set out to prove. Let's look at an example. Here we want to write a step-by-step proof explaining how you know that AE is congruent to BD. So we're looking at AE, this line here, needing to be congruent to DB. Here we'll just set up our statement and reason. It's a little bit easier than a paragraph proof because you don't have to think about wording on it. You just pick a statement and pick a reason. And with this overlapping triangle set, I think it would be easier to draw them separately. All right, so what is our first statement? Well, we want to go ahead and give the things that are given. So angle ADB is congruent to BEA. And again, that was given. What else is given? Well, we have angle B and angle A are congruent. So I'm going to name DBA is congruent to angle, this is EAB. Again, I'm naming the angle in the direction where the parts are congruent. So D was up at the top, so that matches with E up at the top. B for this one was the small one, or was the vertex of the angle. And over here it's A. And then B is on the small side of E, just like A is on the small side of E. Again, that is given. So we want to know if AE is congruent to BD. If we can't prove that by itself, maybe we could prove that these two triangles are congruent, and then we could use the CPCTC. So what else would we need to prove that the triangles are congruent? Right now we have two angles. So we just need a side length. What side length could we use? Well, I see in the picture that AB is the same as BA, right? This line down here at the bottom is the same in each triangle. So we could say that AB is congruent to BA. And that's just the reflexive property, or it's the same line. So the formal wording would be the reflexive property, but if you wrote it's the same line, then of course, if it's the same line, it's going to be congruent whichever direction you go. So now we can prove that these two triangles are congruent. Triangle ADB is congruent to triangle B, E, A. And again, when we write this on our drawing, and we could even mark it up here, we're talking about this, that we just proved that AB is congruent to BA. Now that we've marked it, we can easily see that this is angle, angle, side. Once we have that in our triangle, and on our drawing, we can say AE is congruent to BD. So AE is this one over here. It's congruent to BD. And why is that? Well, we've already proved that these two triangles are congruent, so their corresponding parts are congruent. And AE is the corresponding part to BD. So we've proved the triangles are congruent by corresponding parts of congruent triangles are congruent. We can say that this AE and BD, the corresponding parts, are congruent. We can also use a flowchart to organize our thoughts and proofs. A flowchart is a visual way to organize all the steps in a complicated procedure. For a flowchart proof, we will just box our statement and write the reason below it. One or more statements can lead to another statement, and we'll just go down the page. Look at this next page for a flowchart proof, and let's fill in the missing reasons and statements. Here, I is the midpoint of CM, and I is the midpoint of BL. That's what we're given. We're trying to prove that CL is congruent to MB. Now, I'm not going to mark them as congruent now because that's the part we're trying to prove. Okay, I is the midpoint of CM. That is a statement, and it was given. I is the midpoint of BL. Again, that's a statement, and what is our reasoning? Well, it was given. If I is the midpoint of CM, then CI is congruent to IM. Well, that's because that's the definition of a midpoint, that the two segments on either side will be congruent. So if that's true of CM, what about LB? I think we can safely say that IL is then congruent to IB. And again, definition of a midpoint. Now we have another one over here. Angle 1 is congruent to angle 2. So how do we know that 1 is congruent to 2? Well, like our first proof today, vertical angles are congruent. So you could just write vertical angles. You could add are congruent, but I think vertical angles suffices. We know that vertical angles are congruent. So now what triangle is congruent to what triangle? Well, we have a side and the angle in between and the other side. So at least I know the reasoning that we're going to use. We can start up at the top of this one. So CIL. So triangle CIL is congruent. Now we need to list it in the same order. So C corresponds to M. So MIB. These two triangles are congruent because of side, angle, side. And now the last statement should be what we were trying to prove. CL is congruent to MB. So CL must be congruent to MB because the corresponding parts of these already congruent triangles that we've just proven are going to be congruent. We have been talking so much about how to prove things. We've used deductive reasoning for so many lessons already that these proofs should not be hard. Just go systematically, make sure that you're keeping track of what you have proven and stated so that you can write good proofs, no matter which way you like to write them, flowcharts, statements, or paragraphs.